Hello everyone, I welcome you all on my channel Maths Ki Preet. So if you are new to my channel, you can subscribe the channel for the updates on mathematics. So today our topic is congruency. So two shapes or two figures, two items, two figures or more than two figures or two items are congruent if they are of same shape. These are two conditions for the figures to be congruent and of same size. So two figures are congruent only when they are of same shape and same size. The same size means they are of same measurement. Of same measurement. So if I am talking about the congruency of two lines, this means if AB is a line, say of 4 centimeters, then this line is CD. AB will congruent to CD only when, no doubt, shape is same, and now we have to check the size. This AB is congruent to CD only when CD is of same length, of same measurement, because a line can only have length, nothing else. So AB and CD are both of 4 centimeters, so these two lines are congruent to each other. Now let's take an example of angles. If I am having this angle, say C, and D here, these two angles are congruent only when the measurements of the angles are equal. For example, if the measurement of this is 45 degrees, then this is congruent to angle D only possible if angle D is of 45 degrees. So in case of angles, two angles are congruent only when the measurement of both the angles is same. This is the symbol for congruency. A is congruent to DEF, then sides of triangle ABC fall on corresponding equal sides of triangle DEF. And so in the case for the angles, means AB covers DE, BC covers EF, because these are, I am writing, these are congruent, and CA covers FD, this is D. And same in the case of angles, means angle A covers angle D, angle B covers angle E, and angle C covers angle F. Why I am writing this? Because I just told you that I am taking triangle ABC is congruent to triangle DEF. So when two triangles written as congruent, then AB will cover DE, BC will cover EF, and CA will cover FD. Written here, angle A will cover angle D, B will be same as angle E, and C will be same as angle C will be same as angle F. So they will cover each other. So if we are having congruency of two triangles, we can write the correspondence of vertices from here. So I am writing here triangle ABC is congruent to DEF, means vertex A is corresponding to vertex D, B is corresponding to vertex E, and C is corresponding to vertex F, where I am writing from here A to D, B to E, C to F. This is the 1-1 correspondence of vertices when we are having two triangles as congruent to each other. So from this naming of the triangle, we are getting the correspondence of vertices. So other way, if we are having correspondence of vertices with us, we can write the congruency of two triangles with correct name. So if I have this, from here I can write triangle ABC, this side is congruent to, directly we can write this triangle DEF. So this will be correct always if we have one correspondence of vertices with us, which is always 1-1, which is fixed. We cannot change the correspondence of vertices. Means we cannot write that triangle ABC is congruent to triangle, say, EFD. This is incorrect way to write. So this is compulsory to write the congruency of two triangles, and if we are having congruency of two triangles with name with us, we can write the 1-1 correspondence of the vertices for the triangles. So this was all about how to write the correct naming for the triangles which are congruent to each other. Let's try to understand the concept of correspondence of vertices and how to write the congruency of triangles with this example. So here I am taking two triangles ABC and PQR. So let's see how a student will work on it. At a glance, he or she will write it like AB is equals to PQ, both are 4 centimeter. Then we'll take BC is equals to RQ, which is equals to 6 centimeter. Then AC is equals to PR, which is equals to 5 centimeter in both the triangles. Next, angles are clearly given to us. One can write the equal angles as such. Now from here we are getting A is corresponding to P, vertex B is corresponding to Q in the second triangle, and vertex C is corresponding to vertex R in the second triangle. So this is the correspondence of vertices I am getting from the angles. Always write the correspondence of vertices from the angles which are equal to each other in both the triangles. Now let's see whether I have written these sides correct or not. So A and P, fine. B to Q, B to Q. So this is correct. Now B is corresponding to Q, but I have written B and R here, so this is incorrect. C to Q, this is again incorrect. What is incorrect here? What is the thing that is incorrect here? Just the position of the vertex. So for B I have to write Q, and C is corresponding to R. So position of the vertex need to be changed here, rest is all fine. So if somebody is writing like this is incorrect. No marks will be given to that student for these two lines. So next is A and P. A and P is fine. C and R, this is fine. So nothing is incorrect here. So what was not right to write here is this line. So we can write this as BC is equals to QR, which is equals to 6 centimeter. Why? Because BC 6 centimeter, this is 6 centimeter. Somebody can get confused while writing, so we need to check the angles. B is 60, so we will write Q first, B and Q, then this is 45, this is 45, and C here and R for the C here. So this can be easily checked from the angle. So first always try to write the angles which are equal in both the triangles, then write the sides with correct correspondence of the vertices. Now I can write this as, from this correspondence I can write this directly. ABC, triangle ABC is congruent to what? PQR. We cannot miss. So there are certain criterions to check the congruency of two triangles. Here what I am going to write, A stands for angle, S stands for side. So first criterion to check the congruency of two triangles is side, angle, side. So first criterion is congruent if two sides and the included angle of the first triangle is equals to the two sides and the included angle of the second triangle. For example, if I am taking these two triangles, so if I prove that this side of first triangle is equals to this side of the second triangle and this side is equals to this side, included angles between these two sides, so this is the included angle, is equals to the included angle between the sides of the second triangle, then this criterion gives us the congruency of two triangles. So the two triangles will be directly congruent to each other. Second criterion is angle, side, angle, which means if I prove that this angle of first triangle is equals to this angle of the second triangle, included side, if I am taking second angle, this angle is equals to the this angle of the second triangle, and the included side of the first triangle is equals to the included side of the second triangle. So angle side angle, angle side angle. So two angles and the included side of the first triangle is equals to the two angles and the included side of the second triangle. Then two triangles are directly congruent to each other. Third one is side side side. When three sides of the first triangle is equals to the three sides of the second triangle, then we get the congruency of the two triangles. Fourth one is for the right angle triangle. So if I am having two triangles, two right angle triangles, then if hypotenuse is equals to the hypotenuse of the second triangle and any side, suppose I am taking this side, if any other side, any of the two sides is equals to the same side of the next triangle, then this angle is clearly equal 90 degrees. So RHS gives us the congruency of two triangles. H means hypotenuse, side means any side of the two sides which we are left with except hypotenuse. So right means right angle. So this is the fourth criterion to check the congruency of only right angle triangle. So they are asking us to show triangle AOD is congruent to triangle BOC. AOD is congruent to BOC. This figure is given to us and we have to show AD is parallel to BC. Now this figure is given to us. It's given that AO is equals to BO and CO is equals to DO. From the figure it is clear to us. Let's see how to prove the result. So given, we can write it as given in figure AO is equals to BO and CO is equals to DO. This is given to us in figure. Now to prove triangle AOD is congruent to BOC. AOD, this is the first triangle and BOC, this is the second triangle. So in both the triangles I can write this as in triangle AOD and triangle BOC. These two are given to us. We will write this. AO is equals to BO, CO is equals to DO. This is given. AO is equals to BO, CO is equals to DO. So two sides are equal to the two sides of the second triangle. If I prove that included angle is equals to the included angle of the second triangle, I can directly write the congruency from SAS criteria. So clearly these two lines are intersecting and we are getting a pair of vertically opposite angles which are always equal. Vertically opposite angles are always equal. So here we can write the third condition. There is always three conditions to prove the congruency. Three conditions. Two sides are written. Now we have to take some angle which is equal to the angle of the other triangle. So this angle AOD, angle AOD is equals to angle AOD is BOC. BOC. So what is the reason? Vertically opposite angles. How these two angles are equal? Because these are two vertically opposite angles. So these two angles are equal. So three conditions: side, included angle, again side. These are equal. Now we can write by SAS rule. We have triangle this given in the question AOD is congruent to triangle BOC. First part we have proved. Let's see how to prove AD is parallel to BC. AD is parallel to BC. This thing. Now these two triangles are congruent. From the congruent, what we are getting? We are getting every corresponding side is equal and every corresponding angle is equal. Now every corner means angle from here, what we are getting? Angle A is equals to angle B, A to B, O to O is fine, vertically opposite, D to C. D is equals to C and these were given equal, so the third side will automatically be equal after proving this result, because each side will be equal, then each angle will be equal, but corresponding it should be. So from here I can write as triangle AOD is congruent to triangle BOC. I have to prove this parallel. To prove this parallel, if I write what these alternate angles we are getting, if I write angle B is equals to angle A, angle B, check the correspondence always, BA we can write, and angle C is equals to angle D. Yes, C and D are corresponding vertices, so C is equals to angle D. Why? Because now these two triangles are congruent to each other, so these angles will be equal. Now these angles are what? Alternate angles. This I have written through the congruency, but we are getting the alternate pair of angles. So when alternate pair of angles are equal, then the lines are parallel. So lines making these angles, what are the lines? AD. AD is the line making angle A and D. BC is the line making the second pair. So AD will be parallel to BC. This was what we have to prove and hence proved. What was the result of the lines and angles chapter? That if the pair of the alternate angles between two lines intersecting by a transversal are equal, then the two lines are parallel. So this part is important. Congruency was simple to prove. This was the result from the lines and angles chapter we have done in the previous last videos. So you can check the details of the chapter from the videos. So this was all about today's topic. Hope you liked the video. Hit like and subscribe for more. Thank you for watching.